Okay, let's look at question 2. Question 2 states, is each relation a function? Explain, sketch a graph of each. And we have that. We have, be careful for this question, because it's an x, not a y. It changes. And then we have just a regular parabola. And this is, if you don't recognize it, it's a circle. Okay, so let's go ahead and get that done. Now you're going to have to draw your own axes. I have it all ready for myself. Okay, what's this? This is a line. We can see it's a line. And what we know about the line is that it has a slope of 1, which is the same thing as 45 degrees going up. Oops. That's just perfect. I mean, you have your own problems that you'll run into, but these are problems that I run into here. And let's go ahead and make that, let's make that yellow. Oh, shoot. Is there a way to make that yellow? There we go. Now, you'd think that I don't know what I'm doing, but in fact, I do, because our y-intercept is -5. Okay, so I just moved it down. Now, normally you just start from 5. Normally the way you do it traditionally is to start from the y-intercept of 5 and go rise over run is 1 over 1. So 1 over 1, then 1 over 1, then 1 over 1. I just happen to know that 45 degrees will give me a 1 over 1 relationship. Okay, so, and you'll know that too later on. So is this a function? That's what our question asks. And what that means is you take a ruler, or you just look at it, and you ask yourself, at any given point, at a vertical line, if I draw a vertical line anywhere on my graph, or on my function, or on my relation, how many values for that value of x is there for y? And the answer is 1. And if the answer is 1, then it's a function. So this is a function. Is a function because it's a 1-to-1 relationship. Okay. So next, or for every value of x, we only have one. For every value of x, we only have one value of y. All right, now this one, don't be confused. This is not your regular parabola. In fact, it's a flipped parabola. So let me give you an example. Let's just make a table of values. So I'm going to put x and I'm going to put y. And when y is 0, what's x? It's -3. So at -3, it's at 0. Now what happens when I put it at -2? At -2, -2 square -3 x equals 4 minus 3x equal to 1. So at x, at -2, x equals 1. So at -2, at y equals -2, x equals to 1. Interesting. What about at y equals, at -2? Oh no, my mistake. At -2, it's equal to 1. -2. Sorry, at 1, it's equal to... Jeez, I'm running into problems. Technical difficulties. Let's try this again. At 1, we have -2. Okay, what about if I put... Or is it equal to 1? At 1, y equals 1. Okay, so let's do that. At 1, x is equal to 1 minus 3, which is equal to minus 2. So we got minus 2, 1. Minus 2, 1. Okay, let's look at, y equals minus 1. Well, if I have a minus 1, it's still going to be 1. And that's 1 minus 2. So, sorry, it's minus 2. So at minus 2, x is also equal to, sorry, y is also equal to minus 1. Okay, so what does that mean? Where's it equal to 1? So at y equals 1, let's try that. Sorry, when y equals 2, this might get a little complicated. Why is it doing that? The point is, I'm getting the picture that it's symmetric. I already told you it's like a parabola, but I happen to know it looks something like this. Now, if I do a vertical line test, like so, I see that for any x value, there exists at a specific x value, quite a few actually, places where if I run my vertical line test, I'm going to get 2 values for any x value. Therefore, this is not a function. Okay, let's move along. Okay, so this is question C, 2C. And what do we have here? We have a parabola. Our vertex is going to be down 2 and positive 1. And it's just going to be, it's multiplied by 2. So instead of it being 1, 3, 5, it's going to be 2, 6, 10. So we go 1 to the left, 2 over here, and it's symmetric. And then we go here to number 6, and I don't think we're going to have space to do it anywhere else. Now this here, oops, that's not a curve at all. Closer than what the AI generated. Okay, so this is a parabola. Y for any given x value. For any given x value, there's only one y value. Put it through the vertical line test. Okay, there's only one value for any x value. Okay, so this is a function. Function because it passes the vertical line test. And finally, we have x squared plus y squared equals 4 squared. Now, if you're not familiar with not 4 squared, but x squared plus y squared equals 2 squared, which is the formula for, we have a point all the way over here. It is in fact a circle with radius 2. Is this a function? The answer is no. Why? Because there exists almost everywhere, every time I pass a vertical line through it, almost every time, I get 2 values. Therefore, it is not a function.